Welcome back to the workshop. So those of you who have just joined this video series, the whole purpose of upgrading the CNC machine was I was originally working on a drill press project and I'd done lots of modifications to it. So I swapped out the single phase motor to a three-phase motor, mounted it on the top on some custom brackets. Then I made this control panel on the front for start stop. We got a jog function in there, forward, reverse and so on. And then to power it all and look after it all, I've made this custom control enclosure. And then one of the other features we're working on is a rise and fall mechanism for the table, so it now moves up and down on these linear rails, and we've got a readout on the DRO to show us that height. Now we were in the middle of making the XY table to go on there, and we'd also have digital readouts on there, but the computer broke, so basically I decided it was time for an overhaul for the whole system. It was running on a parallel port, so it's time to go to an Ethernet system. So you can see I've got the back of the control unit here. And I've been making a few modifications to it, so now we've got it hinged, so it's a little bit nicer to work on. And if I just move that up, you can also see I've got a few mods in there. So I've got a new green light, which will be the power, which will replace the old tiny LED. There'll be a reset one that's here, that's illuminated, so that will come on red when it's in the reset, and then you push that to arm the whole system, and the red light will go out, so that'll look a little bit nicer. And then over there, you can see I've got a USB little socket, and that runs down to the back of the computer, so you can just plug your memory stick in there rather than fiddling about down by the machine. So that's the new front panel, and now it's got those hinges on. It's a little bit easier to work on, so let's get started on wiring it up. So I've just finished all the drawings. I haven't really proof checked this to make sure there's no errors, but just to give you a basic idea of what's going on. So we've got the main power, all the interlock systems, safety systems and auxiliaries are all on here. And then on the second page we've got, so this is wiring up of the stepper motors. So we've got the contactor, big main power supply, all the steppers down here, so you'll notice I've got 5 of those, the drivers and the stepper motors, and then the control unit down here, the Ethernet control system, and then all the proximities down here. So that's what we got on sheet number 2, and then on the last sheet, not so much on here, but this is the inverter control, power, speed, and the spindle as well. So we'll go into these in a little bit more detail. Also, so I've been looking around for ages for a free, nice electrical schematic type bit of CAD software. I've been drawing them in Word or PowerPoint or whatever, and I came across this piece of software called, I don't know how you pronounce it, Profi-CAD, I guess Profi for professional. It's got a free version, which is what I downloaded, and there's a couple of limitations. One of them is, let's just go back to page 1 again, well, you can only have 3 pages. So you only have 3 sort of linked pages, and you can have cross-references. Now, of course, you could have multiple documents to extend that, but I think for DIY use, 3 is probably okay. There's a few other limitations, but I haven't looked into it that much. But basically, I think for DIY, it's really good. You've got all your standard terminals in there, symbols, there's contactor symbols, diodes, distribution blocks, whatever. And then there's this kind of nice wiring feature where you can click and it draws the wires in as you click, and you can move them around, and when you move the object it moves the wire with the object. It's just all nicely done. It's purpose made for that. You can add notes. There's a way where you can have some kind of wiring system, so you can ultimately end up with a, what do you call that, a shopping list, or a a list of all the components you need. I don't really need all that kind of stuff. I just used it. It took me about an hour probably to get going on learning it. Took several hours to draw this because I'm really slow and getting used to it, but in terms of just picking it up and getting a feel for it, it was pretty quick. So it's Profi-CAD. If you're designing your own circuits for a CNC machine, download it, have a look, see what you think. I was pretty impressed for basically free. Okay, so let's dive into this. We'll just talk through some of the features. I'm not going to talk you through every single wire, I'll be here all day, but just give you an overview of what we've got. And the way you read these drawings is you kind of start in the top left typically and work your way down towards the bottom right. So we've got our power coming in here through the miniature circuit breaker. These little square bits mean it's got a thermal cutout sort of capability. So we've got 2 poles there. That's a 4 amp type D, so it's reasonably slow acting. Then that powers these 2 power supplies. So we've got 24 volt and a 5 volt one down there. So into there they've got earths as well. That's the P down here. And then they go into a couple of things. So we've got our 24 volt distribution block there. We'll come back to that in a minute. The 5 volt distribution block. And then the 0 return for everything to come back again. The one in the middle is 24 volt switched, so that once you turn the master switch on, which is through here, it feeds 24 volts to this. So once you want it to be live, you plug all those into there. If you've got like ancillaries like lights, water cooling and so on, which you're happy to have access to as soon as it's plugged in, before it's live if you like, then those run off that system there. So what else we got? So we talked about the different power blocks here. We talked about the ancillaries, which are operated via the user control panel. We've got a couple of things here like the power on green LED, so you know you've got power. There's an emergency stop button on the main panel, and also one on the machine itself. We've got a reset system here and reset light. So when you're in reset mode, this light will come on. That's the new light I've got on order. So it will be illuminated once you first turn the system on, and then when you press reset, the illumination will go out, and it's driven via the normally closed contacts on the contactor. So I'll come on to that in a bit. So when you first turn it on, that connection will be made and the light will be on, and then when it's armed, the connection's broken on the contactor, and then that light will go out. So it's a bit of a safety feature that you know the contactor's working correctly. You've got the master relay there that's got the 4 throws on it that runs a number of different circuits. I have drawn a diode on there, flyback diode. I'm not sure I'm going to use that or not. Not sure for the amount of duty cycle I give this, whether I'm going to burn anything out, or I don't think when it flicks and sends its pulse, it's going to go to it's not like it's being driven by a MOSFET. It's not any sensitive electronics, so I don't know. It's a bit awkward to put one in, I've found, whenever I do these. We'll see how we go. I may or may not put the diode in. Same with that one. This is the spindle relay. So you can only operate the spindle relay once the system's energized from here. So there's a feed down to that, and then there's a start stop on the user control panel to start and stop the spindle. Some people like to run that to the motion control system, so you can start and stop it using the G code or just typing in S something or M3, M4. I quite like to do it manually, so I've got like that. I think that's kind of it. So I won't go into detail here, but you can have a look at it yourself there. And basically this energizes everything, enables everything to go. It sends an e-stop OK to the motion control system. It allows you to power the contactor, and it does a self-latching function as well. There's self-latching on this one down here. So that's kind of it. That's the general view there. And then on the second sheet, you'll notice, so I believe the way you're supposed to do this is so you see that goes to AXBB E-stop I5, that's the input terminal 5, but because it's not on this sheet, I'll just put it in brackets. I have seen it had a slash, some people put a slash there, it tells you it's on page 2, but it's only for me, at least I know what that 2 means, that's on page 2, and you'll see that that contactor, that's A2, that will be for the relay, the A2, that will be the ground part of the relay coil. That's also on page 2, and so on. Yeah, some more are on page 2. So let's have a look at what is actually on page 2 then, which is here. So at the top we've got our power coming in through, this time it's a MCB miniature circuit breaker 10 amp type. You need the high current for this one. There's our contactor, and the contact, it's controlled, you can see by the 2 feeds coming in from circuit 1, so over there. So when that master relay trips, it allows power to flow through here, and then that energizes that through the A1, A2 terminals, and that puts power through into the main power supply down here. This is a toroidal type, so you've got your step-down transformer, then you've got your full bridge rectifier there to turn it into a DC, but it's got a bit of a ripple on it, so you've just got a range of capacitors on there just to smooth that out, and there's your 68 volts, or nominally 68, that goes to each of the drivers, and it goes through fuses for each of those. And then down the bottom here you've got the breakout board itself. You've got the step and directions down here, which go through these twisted pair cables into the drivers. You've got power coming in. Now this unit needs 24 and 5 volts, so we've got those there. And then on this side we've got our proximity switches. I'm using proximity for my limits. You can use micro switches, whatever. And then homes, I've also got proximity. What else we got on here? Oh, you've got the e-stop feed from the other circuit. So as long as that's together, that means the other relay, master relay, is energized and everything's good. If you go into e-stop, then this circuit's broken, and then the controller knows as well. So you get a software e-stop and a hardware e-stop all together. And then there's the option for a probe in the bottom there. Oh, and the last one is the Ethernet connection in there. Actually, there is one more, which is, there's a charge pump output there. So it will use that to determine, and I think it grounds one of the relays on the other circuit. So as long as this is happening, it can see a signal coming through the Ethernet system. So it's talking to the computer. It'll ground that pin there, and the relay can be energized. If it breaks contact with the computer, that will break and that will trip the system out as well. I think that's kind of it really. You know, standard stepper motors down there. I've got 5 on my machine. And then I've just got the shields around the outside of each of the cables to go back to earth. So that's that one. And then we get onto this one, which is the wiring for the inverter. It's 1.5 kilowatt unit, you can see there. So the mains power comes in here through a line filter. Also got our earth through there as well. Powers the inverter. And then there's a number of controls for it, which come in down here. So the forward and DC common, those, or digital common actually I think it's called. When those are shorted together via one of the relay terminals, when you press the start stop, it joins those two together on the relay on the other circuit, and then that knows it's got to run forward. And then the speed it wants to run at is controlled by this 10k potentiometer here. It goes into these 3 terminals, VR, V1 and ACM. Now if you've got a different inverter, they often call something a little bit different, but the principle will be the same. And on this inverter you need to set a couple of parameters. This is parameter 1 and 2 need to be set to a 1, and there's a jumper you need to set to V1 as well. And when you do that, it knows to look at the front panel rather than the built-in potentiometer and start-stop. So it knows you're going to do external control. There'll be something similar on your inverter as well, with some similar type of parameters. And then the outputs to the spindle, we've got 3 of those, which are the 3-phase UVW that go onto the motor. I've also got an earth coming back, which earths the main body, which is this one you can see here, and then there's a shield around that back to earth as well. And then finally we've got the water circuit here with the pump, radiator and so on going through that system there. And those are activated via the buttons you saw on the first panel, or first sheet, sorry, that are on the user control panel. Right, yeah, I went into a bit of detail there, didn't I? Anyway, that is how the circuit works. I haven't sort of double checked it to make sure there's definitely no sort of errors or anything, but I think it's okay, and as we start building it, we'll soon find out, won't we? So for most of the wires I'm going to try and add some labels, so if I need to debug it or make any changes later on, I know where I'm going, and I've got a drawing to refer to. So this one is going to be the master switch, so I've just printed that out. Now I did look into, this is just a regular label maker, just makes kind of flat labels like that. Now this tape apparently is good for cables, it's very bendy. I haven't used it before, so see how we get on. It does feel very flexible, so I think it should go around the corners. And then we've got a bit of clear heat shrink that will go over the top, just to keep it wrapped round and stop it coming undone. Again, I haven't tried this, so let's see how we get on. And what was the other thing I was going to say? Oh yeah, so I did look into the proper labels you can get for cables. They're kind of like a tube that it prints on, so you slide the tube over and heat shrink that direct. They are very expensive, the pre-made ones and the tube stuff and the whole printer that goes with it. So we'll just give this a try. So this is what I've already got, so all I have to do is spend a few pounds on the actual tape. So I'll stick this on. I've got my finger marked where it's got to go, because I need to make sure that it's got this kind of split down the middle so you can get it off. So I need to make sure I'm able to see the cable, or see the label, sorry. Let's go out of there. I should have started on the back, shouldn't I? There we go. It's about as straight as we can go. Right. Now is it going to go over the top of itself? Oh. No. Yeah, looks pretty good. So I think this was 9mm tape. That looks like a good size to go around most of the cables I'm going to use. This is one out of the old control cabinet, so you see it's already got a ferrule on it. But I've just tried it and I can actually get the heat shrink over the top. I think for new cables I'll do this first and then put the ferrule on after. Yeah, it's going. And then, to make sure I can get it over there. Okay, I've got it. And then centralise it. Alright, let's give it a go. Little heat gun. Yeah, I'm pretty impressed with that. It's obviously going to take a bit longer, but I think it will look a bit more professional, and as I say, I'll be able to refer back to the drawing if I need to change it or figure something out in the future. Alright, let's get a few more of these done, then we'll bring you back. Hang on a minute. Now I was just about to wire up the reset switch to the relay, one like this that's in the unit. It's a DIN rail mounted relay, and like all these relays, you need to wire up pins 13 and 14 to power. So I've just got my little crib sheet down here because it's quite hard to read all those. So I've just got each pin labelled out down here. And a little while ago I've drawn a diagram like this. So 13, 14, there's the coil, there's the LED, and the only way you're going to light that LED is if you put the plus on this side and the minus on that side. The plus on 14 and then the minus or the 0 on the 13. Then it will light that when it's active. When it switches off, it will go out. Just a thought occurred to me because yeah, I found another wiring diagram where 13 was labelled as A1 and 14 A2. Now on a contactor that would mean the positive is on this side and the 0 or the negatives on this side, which is the other way around. It got me thinking a little bit, so I've just done a little bit of experimentation. Now you can activate that coil if you put plus, whichever way around you connect it, it will still activate. So if we go, let's say, so 13, let's put 13, 0, which is this one, and the other one 24. Get in there without shorting it. Okay, clicks, light comes on, that's active, switch off, light goes off. Let's just turn this off so it's a bit brighter. Let's just do that again. Okay, light comes on, it's active, goes out, it's not. Well, that's the other way around to this labelling system where I saw 13 as A1 and 14 as A2. So that's actually the other way around. So if we put the plus in 13, which is on this side, what you'll notice this time is that when I activate it, the relay will come on, but the light does not come on. Okay, that's on and off. Now, did you see that? When it goes off, the relay, the diode, the LED there, acts as a flyback diode, so you'll see a brief flash when I switch it off. There, let's just try it a couple of times. I'll look down the camera, see if you can see it. So I'll bring you in close. Try once more. They're really active. I'm going to take it away. There. You see the light flashes. So it appears if you wire it as per A1, A2, so this is positive, so positive in this end in A1, so not like that. Then you can get the LED to act as a flyback diode, and as you can see there's a little flicker of light, so it's absorbing that back EMF and saving it going to the rest of the circuitry. So there's nothing else that's connected to these two, it just simply activates the coil or not, and I can't really see any issue if I run it, well I say in reverse, but as I say I've already seen that sometimes this is marked up as A1, which is the positive. So let me know in the comments if you've seen this. Do you run them back this way round? So the LED acts as the back EMF diode, or do you run it with the LED running? In other words, you have these running the other way, so you have your plus into 14 to make the LED come on. I'm going to try it the other way, so it acts as a flyback diode, and we'll see how we get on. Okay, well, many hours later, we've got quite a lot of the wiring done now, so we can probably turn it on and just see if the master relay trips when we operate some of the controls. So we should have the lights working and also the coolant pump for the main spindle. So you can see the back of the switches here. So this is the main on-off switch, so that puts the 24 volts into the rest of the system. We've got a 24 volt light that will light up when this is on. We've got the emergency stop there. The other emergency stop on the machine is not wired in yet, so the e-stop system won't work. This one's the reset switch, so this is a temporary switch in here. It's a momentary one, so you press it, it makes the contacts, and when you let go then it breaks. Just does that momentary reset. Now I've got one on order, because this is just a placeholder if you like, so I've got one on order that's illuminated, so there'll be another pair of wires that comes down, feed 24 volts into that, so it'll light up, then when you press reset and the system's active, the light will go out. It's a red light on there. And that feed comes from the contactor, the two terminals, the monitoring terminals there. I think they're the two normally closed ones. That'll feed that. So when that new light comes in, I'll wire that in. But for now, we've got that temporary reset switch. We've got the main light switch down here that puts the lights on underneath the machine so you can see what you're doing. And then we've got the water pump switch there. So we've got our potentiometer there, that controls the speed of the, it goes into the inverter, controls the speed of the spindle. I've never got around to it, but the intention of this was a display that gave you a readout of the speed, so I was going to have to work out some kind of volts to speed conversion to get this to display the right kind of RPM, so I never quite got around to finishing that bit of the project. This is the start-stop for the spindle. And then these ones we're going to go into, together with this one I think it was, this was the feed rate override. We're going to go into a pokies unit that I've got, and then they were going to emulate keyboard presses, so you could start the cycle, pause or stop, or vary the or override the feed rate here. I just never got around to implementing that, but maybe this time we will. And then there's the back of that USB socket that goes off down the back of the computer. So you can also see in here this terminal block, this row of terminal blocks. This is to feed in any auxiliary device, anything outside the machine that comes in goes into here. So you can see we've got the pump and the lights there, and then the 0 volt return for those. And the rest of these are for all the proximity switches for the home and the limits. and then I'll be able to join those together, because you're going to end up commoning a lot of the 12 volts and the 0 volts for those proximities, and then just running a feed off the black one up to the rest of the machine. So we'll have 24 volts coming to here and 0 volts, and then we can do all the local wiring here, save running huge amounts of wiring around the machine to the AXBB unit. And as we pan up towards the top there, I've just got the master spindle wired in there, and we're starting to make use of some of these distribution blocks. I've just taken the main covers off, but the labels are on the main covers. So we've got the first one is our 0, then we've got 24 volts, and then 24 volts switched, and then our 5 volts. So you can see I haven't really touched that yet. I've just got the main switch gear kind of working for now. So I think essentially we've got enough wired up just to give a little bit of a test for some of the logic systems and some of the auxiliary systems down there. The only thing you may be interested to know is on the back of the master there, you can see that brown wire coming out. At the moment that goes to 0 volts just to ground the other side of the coil, but ultimately that will go to the O1 up there on the charge pump, and then the charge pump will do the grounding. That's just a safety system, so if that doesn't see the computer, it's not talking to the computer, the charge pump won't be active and it won't allow you to run the system. But just for now, because I haven't got any of that wired up yet, we'll just have it running to 0. So I think we can give it a try. So we'll close up the panel. Just put a screw in for now, just so it doesn't fall down. Right, and let's switch on. I was not expecting that. I think we'll just switch off and investigate, because that shouldn't be on until the light comes on. Hold on. Okay, I found the problem. Pretty straightforward really. I just put the power cable for the light in the permanent 24, not in the switch 24. So I've just moved it across one, and okay, let's give it a test. So I'll switch on here. Okay, and the 5 volts have come on. I haven't got that wired up yet, but the power supply's come on. We know the 24 volts works because we've got the light on down here. So let's just do a voltage check. Okay, we're getting our 24 there, but that shouldn't be switched yet. No, that's not working yet. That's fine. And do these lights work? Oh, yes they do. And the pump. Yes. Okay, so the ancillaries work okay, so let's turn it on. And hopefully nothing goes bang. Okay, that's a good start. So that's working properly now. And if we press reset, and the relay, the master relay will trip. Now nothing else will happen because it's not wired into anything else, and it won't latch because I haven't wired up the latching bit yet. I don't know if you'll be able to see it from there, but let's see what happens. Okay, absolutely nothing. Be right back. Okay, I found the problem. The little temporary switch I put in here was this one, and it's just got the light unit on the back. I didn't notice it hasn't got the switch, sort of switch pack on the back of it as well. So I've just swapped those over, and then we got that. So that's a normally open switch. When I press it, it'll close those, and it should trip the relay this time. It's probably because it's about midnight, and after this test I should probably call it a day and come back another time to finish off. Anyway, I'm determined. Let's go and get this working. Let's give it another go. little screw in just to hold it. Okay, hopefully when I press this, the relay will click. Yes, it does. You can even see, I don't know if you can see on the camera, the little flash when the power comes off and the coil dumps all its energy into that. So that's on. Yeah, and it clicks. Thing is, the switch is clicking as well, so they're probably masking each other. What can we do? We'll just put some continuity over two of the pins. Okay, so if we go between, I think it's there and there. Okay, no continuity, press the switch. Yes. Okay, one step closer. Right, I think we'll end on that success tonight at least. Say it's just gone midnight and I think I need to go to bed. So, good progress there. Got it wired up, got the power working now. Now I've got the light hooked into the right terminal. And we've got our reset working. It doesn't latch yet, but that's a simple matter to get that working. The lights work, the pump works. This e-stop would work, but the one on the machine doesn't because I haven't got that wired in yet. But it wouldn't go anywhere because it's not all wired into the main e-stop system. So I'd call that good progress. Okay, I'm pretty pleased with progress so far. Just taking my time, working my way through, checking it at each stage, obviously catching some little silly mistakes there. Yeah, but that's what it's all about. You just check it as you go through, make sure it's working as per your wiring diagram, and build it up as you go through the system, working through the e-stop system and then the safety relays, and finally we'll get the AXBB unit talking to the stepper drivers. So all that remains to be said is thank you very much for watching, and see you next time.